Welcome everybody to Upgrading Emoji, Secrets to Coding Your Own. I'm Bruce Evans from the LINE iOS app client team. Specifically, I work more on the friends list and on integrating some of our shop services, which includes emoji, stamps, and our themes. Now, I said emoji, so that's what we're going to be talking about today. Before I start, I did create a playground. The commits are on this GitHub. The commits try to go in order of the slides. So if you wanted, if it's a little too small or hard to see, you can go to this GitHub, download it, use it, whatever. It should help if you're having trouble seeing or understanding. I will have two caveats on that. The first is that it is not the exact code in the app. I took out some of the error handling and bounds checking, and I went ahead and made it all Swift. We actually have a mixed code base. So it's not 100% the exact same, but it's very close. And then I also made sure that everything runs. So if it's not running, I guess create an issue on the GitHub. I can't really do anything about it right now, but it should be on there. And finally, some of the stuff is not on the slides, just kind of miscellaneous stuff that doesn't really need a big explanation. So if you're wondering about certain things I say and it's not on the slide, it might be in the code, and that might be what you're missing out. So hopefully everyone's had enough time to get this. So let's start. The children of tomorrow will have no understanding of the English language. Now, this is actually a side comment in the Apple's WWDC. I think it was just an off-the-cuff thing that he mentioned, but it does kind of point out what I wanted to talk about. The fact that emoji are used a lot, and part of it's because it's cute cat pictures. Yeah, I mean, we got the little cat smiley, and that's great. But part of it's because text doesn't come with all of the body language that speech does. And that's especially apparent when you're trying to do stuff in English or Japanese, or in Korean, or in any other foreign language. It just doesn't convey the emotions that you're trying to convey. So, if we want to put emoji in our text, how do we do that? How is it represented? Well, most of you probably already know this by now, but it's actually just a Unicode point. Just like any letter, just like any other graphic, A, B, C, A, I, U, all of that is encoded in these little hex points. In this case, the smiley face is the exact same as this hex code beneath it. One of them's rendered, one of them isn't. It's the only difference. Now, sometimes we can even combine them. Just like you have the E with the little accent above it, you can also have combined emoji. In this case, we've combined the thumbs up emoji, which is the standard yellow, with a brown color modifier, and that creates this brown thumbs up emoji. Now, it'd be great if all emoji were just like this, like Mr. Potato Head. We could just pick the smile, pick the eyes, and the color we wanted, match them up, and boom, that's our emoji. Unfortunately, it's not that simple. We got to make our own emoji out of our own Unicode. So, LINE wants to make their emoji. How do we do it? Fortunately, not all Unicode is taken up. We have this supplemental area that's marked for private use. It's a pretty big area with about 64,000 different codes. I think that's probably an okay number for emoji. You might want more. You might want more. I don't think anyone wants less than that. So we took that, and using that private section, we created our own emoji. Now, this is the original version of our emoji. It's called emoticons. So it's not technically the LINE emoji branding that we have now, but it's the same thing. We have a smiling face with moon instead of this number. Now, you probably all know these ones because they're the free ones and they're the oldest ones. They do the basic faces. But just because we made this number doesn't mean that it's automatically translated to that face. In fact, what happens is usually your font takes care of that. So did we make a font and put it in line? Well, before we get there, what about other fonts? I mean, we have the system defaults. We have themes. I mean, people are paying money to get a different font, so if we change that, there's going to be a lot of upset customers. And then, what if our font has versioning? If we add one emoji on this version and one emoji on this version, what's going to happen then? And that's just in Line apps. Let's say you want to copy that emoji, paste it in an email or in your Notes app. What happens if the font in that app is already using that code point? A lot of people have probably already experienced this, especially if you used AU, Docomo, and SoftBank maybe 5 to 10 years ago. A lot of times you would send one emoji, and on the other side, they would see that exact same emoji, but display it as a completely different emoji because they were both private. On the other hand, they might not be using those private codes, but that doesn't mean their font supports it. If you've noticed, I have this kind of weird question mark next to all of my questions. This is actually the moon emoticon that I showed you a couple slides back. This is how it will actually show when it is not presented in, I believe this is Arial font. So, we decided not to go the font path, but we can still do it. So, just a quick to-do. We want to make sure it works with any font, because of all of those reasons we just said. And we also brought up that copy-paste issue when we're copying between apps. So, we decided we're going to keep using that emoji, the Unicode emoji. But we're going to change how we interpret it a little bit. This is the actual spec for emoticons. What we did is we said we're going to use that Unicode point, and we're going to throw away the first part. That's just going to help us to tell what it is. And then we're going to use this last code portion, and that's going to tell us what emoji we're actually using. Now, we did cut it down to only 2 digits, but that's a pretty good number. And if you've looked at some of the older emoji, we didn't have that many at the time. Now, I said we're not using a font, so how does this go from this number inside of a string into an actual emoji that's represented on the screen? Well, we use NSAttributed and more specifically, NSTextAttachment. NS-attributed strings work with all of the normal default AI or UI that comes on the iOS. So that's real easy. And NSTextAttachment, all that does is it lets us put an image into an attachment and attach that to our string. Makes things really easy. Now you'll notice, if you check the developer documentation at the bottom, that's actually not the designated initializer. Technically, we should be using data of type, but Xcode doesn't give me any warnings or errors, so I didn't really care. But if you want to be strict, then that is the correct way to do it. And that's nice. But we don't have the image name, because we all know there's no way in hell your designers are ever going to name anything in hex, unless it's color. So, we decided to name, for the purpose of this demo, we're going to name everything with a number in decimal. So we'll name it 1, 2, 3, 4, 5. But now we have that emoji, that Unicode hex code that we want to convert into a decimal number that we're going to use to identify our image to attach to our attributed string. Now it sounds kind of a little bit complicated, but it's not that bad. So, the first thing we want to do is we want to start out with our string, because that's what we are given. So, we're going to make a category on string, and we're going to call it, we're going to make a function in there. I guess it's an extension in Swift, sorry. Category would be Objective-C. So we're going to make an extension with a function called showEmoji, and that's just going to return an NS attributed string for us. So going over what we're doing, we're going to look at that string and we're going to grab the first emoji we can find. We do this since we know that we're inside that private use set, we already know what set it is, so we just have to call the range of character. That's going to return a range, and since it's the first one that's detected in the string, we know that everything up until our current emoji is just a regular string, something we don't have to worry about. So we're going to take that portion, and we're going to put it in an NS mutable attributed string. Continuing on, we also know that our Unicode, the Unicode that we're looking for, is one Unicode scalar, which makes things really simple. We just call first on the scalars we get from that range, and then get the value of that. That value is going to return the decimal value. Once we have the decimal value, we just plug that into our NS text attachment, just like we mentioned on the slide before, and then append that to our string. Now, that takes care of the first emoji, but other than maybe me, no one puts one emoji at the end of their sentence. I think my wife puts like 6 emoji at the end, and that's minimum. So what we want to do after the first emoji is be lazy. I like being lazy, so what I did is I said, you know what? I know there might be more emoji, but I already found out how to get one emoji, so let's just recursively repeat that until the end, and then just append that to our string. Now, if you're following along in the playground, you can run it now, and you'll notice that you get this hello attributed world string. I've kind of cropped it a little so it fits on the slide a little better. And you'll also notice that we didn't touch fonts yet. But we also didn't address the copy-paste issue. And it might be a little hard to tell, but that's clearly way bigger than the text. And if you have to go through PR, they're going to complain that, hey, we cut the logo off, which is not a good thing. So eventually, we want to solve that too. Now, Line did solve both of these in the emoticon spec. However, it does require some subclassing, and for the purposes of the demo, the emoticon version 2 spec also requires subclassing. So I'm just going to kind of put those together, but just keep in mind that you can fix this without using the next spec. Now, the next spec looks like this. We've expanded the emoji we're using. We called this deco emoji. And the reason for that is most of the new emoji we added were the ABCs when you type a single letter and that thing pops up. As you can see, we've gone from 1 Unicode hex point to 3 hex points and 1 suspicious word. Sorry for the joke. Now, looking closely, these 3 points have 3 different purposes. The first one is a package code. This is going to work just like stamps do. We take the package, and then we take the second code, and that tells us what emoji we want inside that package. That lets us download multiple packages, so we don't have to download every emoji known to man at the same time. Next up, we got a keyword. And that's what we want to use when we're copy and pasting. Because if they can't show that emoji, then we want to at least show what the emoji meant a little bit. And finally, we just have this delimiter at the end. That's just to tell us that, hey, this is the end of our spec, this is the end of our emoji, and we can keep going on normally after that. Now, I will point out that we do have the package version and a package ID. For this demo, we're not going to talk about the package version, but we will talk a little bit about the package ID later on. Just keep in mind that that is there in case you ever wanted to use it. So, I said we needed to subclass. Well, let's get to that. We have a lot of extra information, so we might as well subclass that. And I think we'll use NSTextAttachment. I've called it emoji attachment. And as you can see, we've added the package ID, the version, the emoji code, and the keyword. This is everything that was included in our spec. Now, inside of our init, we're going to set all those items. And, just to keep it clean, I refactored some stuff and moved the message or the image attachment into our init method. So all we have to do is provide those 3 pieces of information, and we're good to go. We can show our emoji. But since we're already in the subclass, and I said that we did need to subclass to fix some of our other issues, we're going to move on to those before we run this and see what it looks like. NSTextAttachment conforms to NSTextAttachmentContainer Protocol. This is obviously a Objective-C protocol, as you can see from the very, very long function signature. But basically, this protocol lets your text attachment tell the layout system what it needs to be shown. In this case, we're going to give it a CG-rect, so we need a position and a size. And since size is what we're looking for, this is the exact method that we need to override. We're going to do a pretty simple override in here. Obviously, if we have no image, then it's 0. We have nothing to show. If we do have an image, though, we're going to take the line height, and we're just going to scale our image down to that. This is just a simple thing. We want to make it small. That's it. Once we've scaled it down, we return that rect, and it should get our emoji working, is what I want to say. But remember, we already moved on to the next spec. So we need to go back to our show emoji function that's on our string attachment, or our string extension. And we need to modify it a little bit in order to get it working again. Well, the piece we need to modify is right in the middle. So after we get our first emoji, and before we recursively call ourselves, we need to change some things. First up, we're looking for 3 Unicode values now. We've already got 1, so we're going to grab the next one and the next one. That's 3. So I got to point it this way. The package ID and the emoji ID, so these are I believe it was called the sticker code back during our original spec. These, we once again need the decimal values, but that's a pretty simple thing. We already have done it before, so we'll just copy and paste that kind of code. Now, the keyword seems a bit tricky at first, but since we've already found the range of our second Unicode, and the range of our third delimiter Unicode, we can use those ranges to pull out the keyword. And with those 3 items, now we can make our emoji attachment. Now we can finally run the playground. If you run it now, you will see that it still works without any fun. And the image size is a lot better. It's pretty zoomed in, so it looks a little grainy, but it should look a little better on the playground. Now, we still didn't fix copy and paste. And if you really were paying attention, you'll see that we have a package limit now, because our package is limited to 2 hex characters. Right now, we're just going to put that on our bucket list. What we want to do is take care of this copy-paste. So, right now, if you copy and paste, what do you think that's going to look like? Well, right now, it's just going to be nothing. An NSTextAttachment does not actually copy and paste anything. It just is a nothing. There's nothing there. It'll copy and paste text, but not the attachments. What we want to do is we want other apps to be able to show at least the feeling behind our emoji. So in this case, we want to say suspicious. But if we copy and paste inside of our own app, we already know what the emoji is. We know how to show emoji. So why aren't we going to show our emoji? Fortunately, for the other apps one, that's really easy. As you can see, suspicious was also our keyword, so it just added some parentheses. So we just add some parentheses. We'll call that copy text. Now, just because we made this copy text property doesn't mean it's actually ever going to be used. So we need to make our own copy method. Since we're copying an NS-attributed string to begin with, we're going to make another extension, this time on NS-attributed string, and we're going to call it copy to pasteboard. It doesn't really matter what you name it at this point, but what we're going to do is we're going to get a copy. By getting the string value of NS attributed string, we get only the text. This means that our text attachment is now gone. Then, we want to enumerate over all of the attributes on the string. We could have also used enumerate attribute without the S, and then specified the attachment like we do in the guard. But it doesn't really matter because either way, we're going to have to guard to make sure it's an emoji attachment. Now, keep in mind that when we are replacing a single emoji with that copy text, the text is going to shift as we move along, which means indexes are going to shift. And if our indexes are shifting and we start putting things in and out of that text, we're going to run into issues once we have multiple emoji. So, we are going in reverse. We're just going to ignore those issues because we already dealt with that portion of the string. Once we have the index, like I said, we're going to replace the characters. Technically, we're not replacing anything because the NSTextAttachment is gone, but we're going to insert these characters into the string. And finally, we put that on the global pasteboard. Now, just because we made this copy method also doesn't mean it's going to work because the system doesn't know about it. Fortunately, UI Responder Standard Edit Actions Protocol is a protocol that works on all of the UI responder, or all of the first responders of your UI in the app. It has a lot of really nice functions that I didn't even know existed, so you can check that out at the documentation there. But for copy and paste, it has the basic cut, copy, paste. So what we need to do is just make sure that on all of our UI objects, we take this copy method, override it, and just redirect it to our copy to pasteboard method. That way, we can copy it, and when we paste, we already have it working. Unfortunately, our app still looks a little suspicious. Once again, sorry for the suspicious joke. What we wanted was the emoji. But right now, we're not taking the emoji. In fact, we're doing the opposite. We're taking text and putting it where the emoji used to be. So, how do we make that emoji show up? Well, we know how to show emoji. We know it originally started as a string, so why don't we just put it back? You know, convert it right back into our spec text. So that's what we're going to do here. And we're just going to call it formatted text. It can be spec text, whatever. I'm not good at naming. But we just copy it back in and create our Unicode points, our keyword, and then our terminator. Now, obviously, because we're copying the string, we've got to go back and modify our copy method. Now, rather than replacing what we've already done, we're just going to add to it. We're going to do the same thing where we create a string without the attachments. Except this time, instead of using the copy text, we're going to use the formatted text. So now we have two strings. We have the pretty string, which has our copy text for other apps. And we have this internal string, which is going to be only for our app. One of them has suspicious in there, and one of them has our encoded scheme. What we need to do is put our encoded version on a private pasteboard. Now, this pasteboard is only accessible to our app or any app in our app group. By doing this, we have two pasteboards that we can choose to use. And since we have two pasteboards that we can choose to use, we need to know when to use which one. Now, if you go back to where we did the copy and we just redirected everything to our own copy method, with the two pasteboards, we can do the same thing. We'll redirect all of our paste messages to our own attribute string from clipboard. And this is really simple. All we're going to do is, if we have our private pasteboard has anything on it, that's what we paste. If not, fall back to the global. Now, I will mention, since we have two pasteboards, there's an issue with syncing, but as long as you're watching for the UI pasteboard notifications, you can take care of that. You'll be able to tell when it changes and what it changed to so that if you need to, you can erase the internal string. If you run it in the playground, nothing changed, except that if you look at the code, we've copied and pasted and then shown it. So technically, things did change. It just doesn't look very good on a slide. You'll notice we fixed the copy-paste. Image size is good, still good. Font's still working. But we still got that bucket list package limit. And this really isn't an issue until you really want to expand your emoji. Right now, LINE Emoji allows people to use it, and Creators LINE Emoji is going to be opening soon. So that means we're going to hit that package limit fast. And that is where LINE Emoji comes in. This is the actual LINE Emoji spec, the branded version. Technically, they're all LINE Emoji, but this is our branded version. And in this one, we've changed the spec yet again so that it looks like this. We've gotten rid of the Unicode, which is great because I hate using Unicode, and I'm sure everyone else does too. But in exchange, we're using some extra metadata that's going to be attached to the string. Our metadata is going to be in JSON, and at any time we send a message or change our status profile, this metadata gets set. What we're really interested in is this resources portion. As you can see, we're still keeping our product ID, which is just our package ID. We've got our stick-on ID, which is the specific emoji in that package. And then we've got our version. What we don't have is the keyword. But that's actually in the spec, or in the string already, because that's what we were showing instead of the Unicode. But we do have this S and E. Now, this is super secret, but that stands for start and end. Those are actually the indexes for where that start and end keyword is, where the keyword starts and ends in the string. Now, some of you may be wondering about the stick-on ownership. Technically, when we send this JSON metadata, if the user has end-to-end encryption enabled, this entire replace portion is going to be encrypted. That's because someone could write, a ransom letter using the decomoji. Everything's an emoji for ABC. So all we want to know is, does this person own this package? Because we do have paid emoji now. We want to make sure that they're not trying to steal it. So this is the only part that would be unencrypted, and it's mainly used on the server side to just check and make sure that that person owns those emoji. Now, we have the start and end now. We've got the product ID, we've got the stick-on ID, and we've got the version. So our emoji attachment class is going to be getting a little big with a lot of properties. So for now, we're going to pull that out, and we're going to make a struct called emoji. This is just everything we had in our emoji attachment class, except we've added the start and end. Now, this is one of the points where I'm going to mention that we do have in the code, the start is going to set the end automatically. Later on, I'm just going to set the start because I'm lazy, like I said before. So just keep that in mind when we go on there. Now, I also moved over the image URL and the copy text, things like that. All of that's been moved over to the emoji struct. Our text attachment is just going to take one property now, and that's going to be this emoji struct. We still need to keep it subclass because we still need to keep the size at a reasonable size. Now, because we have this start and end, though, we've got to make sure that we're setting it every time we put a new emoji in. So what we need to do is just add a quick helper method. That helper method is going to go through and set that start for us. Now, what's happening here is we're just enumerating the attributes. And anytime we find an emoji, we're just going to append the length of that. That way we know exactly how long the real string is. Not the string that we're showing, but the real underlying string. And then we just set the length. Or we set the start to that length. And append the emoji. Okay. I know I said metadata and made a big deal about it, and then I didn't actually use metadata. But that's because we didn't encode or send anything yet. So, remember autocodable came out with Swift 4? Sounded really cool. Can't use it yet. If we use the auto-encodable right now, it's going to encode our product ID, our stick on ID, our version, our keyword, our start, and our end. But remember, we're using our super secret S and E instead of start and end, and we don't want the keyword in there. What we can do, though, is by providing this coding keys, which conforms to coding key protocol, we can define exactly what we want to encode, and we can even say, hey, for the start, we want to encode that, but we want to call it S. That's what this coding key conformance is going to give us. Now, we don't need to write our encode method, because the rest of it will go automatically, which is awesome. Unfortunately, it's not going to work that way for decodable. Because we don't have our keyword in here, we can't use the auto decoding. What we can do, though, is it's JSON. We can decode it to a dictionary of strings. And we do have the keyword. It's just in a different place. So we're going to make that an init method that takes those dictionary strings. It's going to take the string we have. And then we decode those. And when we get to where we need the keyword, we just use the indexes that we have for start and for S and E, or start and end. And we can pull our keyword out of the original string. Now, we did have our show emoji function. And that was only looking at the string. Now we've got all these emoji structs everywhere. So we're going to change our function. We're still going to call it show emoji, because I like the name. And because we just are adding some emoji to it. This is show emoji. It's going to take an array of emoji. And going through, just like we did with copy, we're just going to replace the characters. Now, keep in mind, once again, that because we're working with the indexes, we're going to go from the end of the string to the beginning. We don't want things shifting over, because that's going to throw off the rest of our stuff. So we go from the end, and anything that's thrown off has already been changed into its emoji counterpart. Now, I mentioned copy, which reminds me we got to go fix our copy method too. Fortunately, that one's going to be easy. Where we were getting our internal string, we're just going to switch to an array of emoji. Then, at the end, when we need to copy and paste, we got JSON, so why don't we just use that? Just encode it back to JSON, put that on our pasteboard. Paste is going to change a little bit more than that. First of all, we need the string to start with. So now we have to use both pasteboards. We can't just say one or the other. Also, we have that JSON object on our pasteboard. So we're going to take that, we're going to decode that, and turn it back into our array. And since we already know how to take an array of emoji and a string, we can just call show emoji on our string and pass it our emoji. Now, if you run the playground at this point, you'll see that we have our third version of our emoji. It's small. We've copied and pasted it. And we have no image size. So this code is all on the GitHub. And it is under Apache 2.0. So you can take that, use it, with the asterisk that this code doesn't have any error handling or bounds checking or anything like that. So it's maybe not production ready, but you can copy paste it, take it, fix it up, whatever you want. If you have any questions, this is my line ID. Obviously, I'm from Line, so I figured I should probably give you my line ID. But I know a lot of people don't like giving out their private line ID. So I also have my email address, my Twitter, and the GitHub. Now, Apple always says one more thing. And I'm not going to say that, but I do have one more slide. And it's called Bug Bounty. I just gave the real spec out to everyone. So this is actually, those specs were actually the real specs that we do use. The code might be a little bit different because it's got a little extra error handling. But it is the real way, the real spec. So if you can break it, and you can make it unsecure or whatever, if you go to this site and tell us how, we'll give you free money. Which is great. Not that I know, because I got to work hard for my money. But yeah, so keep that in mind. If you have any issues or you find any problems, go ahead. Go to this website. Give us a heads up. If it's a legitimate bug, we'll fix it and get you a check. Also, I didn't discuss backwards compatibility during the talk, but I did include that as a final commit on the GitHub, if anyone's interested in that. Or you can come to the Ask the Speaker later if you have questions about that stuff. And that's the end of my presentation.